Alright, in this video I'm going to go over domain and range. We're going to talk about how to find the domain algebraically and graphically, and we're going to talk about finding the range just graphically. Alright, so right off the bat you should have done some of this stuff before in a previous math class, and if you're in my pre-calc class you should have already done the Desmos activity. If you haven't, do that one first, and then this one will make a little bit more sense. I'm going to talk about some set notation stuff too, and that's going to be new to some of you and not new for others. So just diving right in here, we have some instructions. Let me try to zoom in on this. Algebraically, find the domain of the function below. We have f of x equals 5 divided by x minus 12. Alright, so I already filled in the notes. We know this right here is going to be my answer. Okay, so I'll read the answer for you. The domain is the set of all x's such that x cannot equal 12. Why is it that x cannot equal 12? Well, let's think about what happens if it was 12. If I plugged in 12 right here, I'd have 12 minus 12, which is 0, and I'd end up with 5 divided by 0. Well, you can't divide by 0 in math. It's not allowed. It's a rule in mathematics, you can't divide by 0. Alright? So, what's the takeaway? You're not always going to be given this problem, but you'll be given a lot of other problems where you have a fraction. So what your process then is to figure out when is the denominator going to be 0. In this case, it's x minus 12 is the denominator, so I set up a little equation, x minus 12 cannot equal 0. And so if it was a different thing, if this was 3x plus 17, you would say 3x plus 17 cannot equal 0. And you would solve for that x value so that you knew what x value should be eliminated from the domain. And so reading this again, the domain is the set of all x's, so every single x value in the real number system, such that x cannot equal 12. Now I said the real number system, yes, I'm comparing the real to like the imaginary, so like the square root of negative 1, which we'll get to in a second. So anytime you see a fraction, be looking for when the denominator is 0. That's going to be the process. When you have a square root, alright, when you have a square root, we don't have any division going on, so we're not as worried about dividing by 0 here because it's not even happening in this equation, in this function. We have the square root of x plus 4. So I thought about x plus 4, that seems to be important, and the idea of a square root, right? So like the square root of, let's take a number for example, square root of 4. What's the square root of 4? 2. Why? Because 2 times 2 is 4. What's the square root of 9? 3, because 3 times 3 is 9. Okay, what's the square root of negative 4? Well, that's where you need an imaginary number. What about the square root of 0? Square root of 0 is 0. Why? Because 0 times 0 is 0. So any positive number, I can take the square root of, and the answer would be a positive number. 0, if I take the square root, I get 0. What about negative numbers? If I take the square root of a negative number, like the square root of negative 4, I need imaginary numbers. I need they're called complex numbers, part of the complex numbers. And so I want to look at when are these x values, what x values are going to cause x plus 4 to be negative, right? So I want x plus 4 not even just to be negative, to be 0 or positive. Hence this inequality. So x plus 4 better be greater than or equal to 0. I solve that, I subtract 4 from both sides. I get x is greater than or equal to negative 4. And so then I write my final answer. The domain is the set of all x's such that x cannot equal, or x better be greater than or equal to negative 4. Alright? That's how you do that part. I'm going to continue on talking about some square root functions and some other rational functions. Here we've got almost the exact same thing as my example. So it really shouldn't be any surprise. These are probably the easiest to solve. You're simply taking whatever's underneath the radical, the square root of x plus 8, so take x plus 8. That right there, whatever's under the square root, better be greater than or equal to 0. So if I were to solve this inequality, x plus 8 greater than or equal to 0, and solve that, I would get this answer. My final answer, since it's asking for the domain, is this right here. This tells me what x values work for this function in the real number system. Over here, we've got a fraction, a rational function. We'll study rationals later, but this is a good introduction to it. What's the domain? Well, what x values won't work. And maybe by looking at it, you might be like, man, that's tough to tell. So you go back to that process. You know that I can have anything on the numerator. 0 can be on the numerator, but the denominator, we can't have 0. So what do we do with this 5x? Nothing. We don't do anything with that 5x. We leave that alone. We just investigate x squared minus 9x plus 20. I want to know when that equals 0. You can see I wrote it down like that. I used a diamond to factor it. I got my answers, and I wrote my final answer here. X cannot equal 4 and 5. So the set of all x's such that x cannot equal 4, comma, x cannot equal 5. And that's exactly how you would write it if you have more than one number you're trying to eliminate. Sometimes you'll have x cannot equal 4, comma, x better be greater than or equal to 2, or something else. And if you had a third item, you would separate it with a comma. All right, so what about this last example over here on the right? Before we get to the graph, we've got almost the same thing. The only reason I put that there is because it's a preview of something that you'll see in calculus when you look at the graph. In other videos, I've explained this in more depth, but basically, it's the same exact process. It's actually easier because the denominator is already factored. So you can see x better not be negative 5, because you'd end up with 0 times negative 8. Negative 5 minus 3 is negative 8, so 0 times that would still be 0. We wouldn't care what the numerator is. We would just want to eliminate negative 5 from the domain. Even though these factors would cancel, you still would eliminate negative 5, because if you were to look at the graph, you'd notice that there'd be an undefined location at x is negative 5. 3 gets eliminated also for the same type of reason. All right, so I'm going to go back up now to the graph. We're going to talk about how to look at a graph for domain and range. Okay, so the graph. I kind of highlighted it again for you, and so hopefully in your notes it looks okay. The domain is the set of all x's such that x cannot equal negative 2. Why not? Well, here's the x-axis. So what happens in x is negative 2? There's a vertical asymptote here. The asymptote is where the graph is approaching towards positive and negative infinity. So towards negative infinity on the y values, the graph is getting really close to negative infinity and positive infinity from the other side, right? So this graph gets really close to negative 2 as an x value, as y's are getting really small over there. So we have to eliminate negative 2 because it never gets to that x value. Similarly, for the range, which is the only thing we haven't done, we eliminate 3. This is a y value of 3. The graph gets very, very close to 3 towards negative infinity for the x values and positive infinity for the x values. This graph gets really close to 3. So we eliminate that from the graph. It never actually crosses that. We'll talk more about this type of a graph, which is part of rational functions, in another unit. But for now, this is what you can do. You look for those asymptotes. I'll try to put them in the graph for you, and we'll study more of that in a bit. So the last thing I want to talk to you about is the set notation that I mentioned. Okay, so I wrote some notes down. I'm going to put down another piece of paper. Boom. All right, so set notation for domain. All right, the domain, or range really, the domain is you're always going to start off like this. This is kind of the frame for every single time you're writing the domain. Now, if you've learned about writing domain with a bracket like this and a parenthesis, we're not going to use the brackets and parentheses for domain. We will use these for other situations in this chapter, but not for domain. Your book uses this set notation for domain when you're doing those practice problems, so it's important that you know it. So this is set notation. This is kind of the frame for it. It's always going to start off like this. I should see this every time for domain. Things that'll change will go right in here. Now the exception to that is, what if it's all real numbers? Like what if you had an equation like y equals 3x plus 7? What's the domain of this function? All real numbers. Why? Because I can plug in anything. There's no fractions here. There's no square roots. There's nothing to really worry about. There's no illegal things that happen in math that's going to keep me from getting a real number out. I can plug in anything here, any real number, and I get a real number as an answer. So in that case, you don't need to do all that. You could just write all real numbers. If you've been taught this thing, cool. If not, don't worry about it. You could have also just you could also write negative infinity is less than x, which is less than positive infinity. That'd be another acceptable answer. But we looked at those, how this is going to change. So to read that out loud, I kind of wrote it in words. It's the set, that's this thing, of all x's, such that, and that's that vertical bar. So it's, again, the domain is the set of all x's, such that, and then you would list out like x cannot equal 5 or whatever goes there. That's where you're actually thinking. Same exact thing for range. If it's range, the only thing that's going to be different, you use R, the set of all y values, such that, blah, 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 and then you close the set. That's what you're going to do for domain and range. You will not use the bracket or the parenthesis till later on. Okay, you'll use that when you're doing intervals for increase and decrease and some other stuff. I hope that helped.